Now again, this work is work you've done in the junior courses, maybe year 9, maybe year 10. But what we want to do is expand these brackets. And what we want to have to do is take the term inside this bracket and multiply every term inside the bracket by the one outside. And that's how we expand brackets. So if you've got to take a few things into consideration, we've got to make sure that we're understanding our indices laws so we can multiply it out, know how to multiply two terms, but also we've got to be really careful about the signs. And as I've tried to put it there, whether it's positive or negative. But that's the whole idea of expand and simplify brackets, is to get rid of whatever grouping symbols they are, whether it's a parentheses, whether it's a bracket, or whether it's a brace. There's three different ones, but that's what we're trying to do in this one. So the 4x times the 5x gives us 20x squared. 5 4s are 20, and x times x gives us x squared. And then the 4x times 7, well, 4 7s are 28. And the positive times the negative gave us a negative 28x. So for 2, here minus 4 times 5 gives us a minus 20, and x times x gives us x squared. But the minus 4x times the minus 7 gives us a positive 28. So be really careful. That's where the main error I see with these types of questions is the multiplication of two negatives. So when we got a negative outside in this bracket, then that's where it starts to make the error. So have a look through. Every term's just getting multiplied every time. Minus 7a times 2a, minus 14a. Minus 7a times minus 3b, positive 21ab. And then minus 7a times positive 4c is minus 28ac. So you might have done all these already and you're just checking these, but just be careful when you're expanding out, multiplying the terms out like we've done before. Multiply the numbers, multiply the terms, and get the indices correct. 2 plus the 3 is the 5, because we're multiplying 2 with the same base. So, and be careful about the signs. Now we can see the same thing here. So this one usually works out pretty well. Like, these are pretty well done by most people. This one is where it's going to cause the problem. The big error we're going to see would be a negative 6 there, because people miss the minus 3 times the minus 2 to give us a positive 6y. So we'll get the error there. Same thing here. And that's where you see it in exams, and you probably recognise what I'm saying because you've seen it in exams in the junior school, that we get these minus signs and minus. That's the one people like to throw in, because they make those errors. They get that sign incorrect at that point. So that's what you've got to be careful about. Also, just be careful with because a lot of times you're concentrating on your expanding, you're not concentrating on the collection of like terms there and getting the numbers correct and the signs correct there. So be really careful with that too. The other ones we start to get are what we call binomial products. So we've got one bracket times the other. So what we're looking with this situation is to take every term in one bracket and multiply it by every term in the other bracket. So the a times the c gives us ac, a times the d gives us ad, then b times the c gives us the bc, and then b times the d gives us bd. So we end up with 4, and sometimes depending on whatever the terms are here, we might be able to collect like terms. You might have used something like what they call the FOIL methods in some of the texts. So if you've used FOIL, then you can go ahead and use that. I'm not one to say you must do it this way, or if you've got techniques that you use and that makes you get the answers correct every time, then that's not a problem. If you need to expand it out like that and expand out the brackets, so x times the x plus 6 and then the 3 times the x plus 6 and expand out that way, that's fine. If you go straight from that line to that line, that's okay as well. And if you get confident enough, then if you can start to go straight from one line and just do our answer, then that's fine too. Realize that if you're working that way, that you've got to be really careful. But when it's simple terms like this, sometimes it's not too bad to do. Sometimes I need to go to this line, depending on what the expression is, but sometimes it's not too bad to be able to go straight to this one, because I'm confident enough with my collection skills and my addition skills there. So that's up to you how you go about it. The idea is to make sure we get it correct. So whether we use this method, the FOIL, and how many lines of working you take, that will depend on you and how much confidence you have in the work that you are doing. We also have some special binomial products. So the idea here is to try and remember these special ones. Again, you might have remembered these ones, and that if you have at this point in time, that's excellent. But basically, we've expanded it out like we've done in the following section, the previous section, sorry. So, and the idea is that we get a plus b times a plus b. That will expand out, and we collect it down to a squared plus 2ab plus b squared. The only difference for this one, if it's the minus there, we get a minus there. That's the only difference. Plus, plus, minus, minus. So, but by knowing these two expansions starts to save you lots of time and effort. And that's what, again, what you're trying to do is become better mathematicians, in that you're going to save yourself time and effort because you can remember certain rules to follow. So again, if we can get to the point where we can just go p plus q all squared is p squared plus 2pq plus q squared. 2x squared plus 2x plus 3y all squared is the 4x squared plus 2 times x times 2 times 2x times 3y gives us 12xy, and 3y all squared is equal to 9y squared. What we've got to be careful about is the situation, and I still see this. I've marked the HSC for a number of years, and I will still see people expand this out and go, well, that's just 9 plus x squared. That is not 9 plus x squared. Try and put two. If you're thinking, well, why isn't the case? Have a look if you've got 3 plus 4 all squared. Now, if you try and compare that to 3 squared plus 4 squared, then putting numbers in starts to prove it. 3 plus 4 is 7 squared, which would give you 49. 3 squared is 9. 4 squared is 16. That does not give you 25. Those two are never equal. So do not ever do that situation. So really be careful with that. That 3 plus x all squared expands to 9 plus 6x plus x squared because I'm using this rule here. Okay? Or I've expanded 3 plus x times 3 plus x. So be really careful with those expansions and make sure we never, ever, ever do that. And then we have another expansion here, and this is one where we've got a plus b in one bracket, a minus b in the other bracket. Some of you may know these as conjugates, binomial conjugates, because they're the same terms except the sign is different. So that's what a conjugate means. It's exactly the same algebraic terms or numeric terms, but the sign is different. And that gives us a nice expansion of a squared minus b squared. Again, a times the a times minus b times a, b times minus b. That'll expand out and collect our terms, and we come down to a squared minus b squared. We call it the difference of two squares. And it's very nice because all we need to do is see that they're the same terms in each of the brackets, but different signs for those. And we're able to say, well, that will just be the 2x all squared gives us 4x squared, and y squared, y and square it gives us y squared. So 4x squared minus y squared, a squared minus 4b squared, okay, because it's always going to be minus in there. There's no way we're going to get a squared plus b squared. Doesn't happen no expansion gives us that in our real number system. So there we go. There's expanding brackets and hopefully some techniques you're able to pick up to make life easier for you, so that it makes your algebra easier to do as you go along in the course.